So this is a real honor. We're continuing in the spirit of our 11 sessions in the reality series. I hope you're okay with my classifying you as a realist in the reality series. Um, and we're honored to have J.D. Stillwater with us as our speaker tonight. And some of my introduction will be in J.D.'s own words from his website, which means I won't be able to misrepresent you. Um, and he says, my mission is to share revelations and insights from science with as broad an audience as possible, nudging global culture towards a new level of thinking that's aligned with how reality works. More sustainable, connective, inclusive, humble, graceful, and integral. He goes on, we can do better, but as Einstein said, we cannot solve our problems with the same level of thinking that created them, which I think is really a nice quote. So where do we find a new level of thinking? So JD, hopefully this talk will help point the way to how we can do that. After a 24-year career teaching science in secondary schools, classrooms, JD now shares the awe, wonder, and spiritual depth he experiences from the findings of the global scientific endeavor. So that's all very dry. Now I want to give you a piece of color. Word on the street is that JD delivered a baby as the sole birth attendant on a bus. Yes. So now I'm going to ask you to kindly wipe that from your vision because it will make it very hard to think anything else. JD, it's all yours.
Thank you, Steve. That baby happens to be our daughter, who is now a UU minister in fellowship, serving the U.S. Navy in San Diego. I'm here to take you on an exploration of the spirituality that I find in studying science. And you might be thinking, really? Science? Spirituality? Well, take a minute and just turn to someone near you and come up just for yourselves with a brief definition of spirituality. Doesn't have to be perfect. 5 words or less if you can. What is spirituality in the first place? It doesn't have to be perfect. We'll give them a minute. All right, I'm going to take that lull as readiness. So where's the mic? Let's get ready. What did you come up with? Spirituality, what is it?
Trust in the power of the unseen.
Trust in the power of the unseen. Back there.
Indra's web.
Say it again.
Indra's web.
Indra's web.
Belonging to something greater.
Belonging to something greater, yeah.
Uplift, mystery, and awe.
Uplift, mystery, and awe. Well, these are all great.
The science of human evolution.
The science of human evolution. Okay.
There is no one definition.
I like that. Yeah. As we're hearing, right? Many ways to think about it. Any others?
I'm taking this from what you said, which is believing in something that you can't see.
Okay. Well, the culture wars want us to think of faith and spirituality as diametrically opposed to science and reason, or at least something different and unrelated, right? And honestly, I'm tired of that whole debate. For me, the spectrum lies between dogma and ambiguity, between separation and connection, between self-righteous conviction and acceptance of mystery. And culture wars are waged by people who sit on the same end of my spectrum. So this workshop this evening is an invitation to shift towards this end, based on what science is revealing about natural physical reality. This mic just feels really hot. Can we bring it down a little bit? I can talk louder if we need to. Working on it. All right. So the problem with that old view is that science refuses to stick to its end of the dichotomy, right? It keeps revealing things about nature that conflict with people's religious beliefs, like in Galileo's day, right? And today too. And many people today see a distinction between spirituality and religion, with spirituality not so much about beliefs, but rather a process of becoming. Spirituality as transformation. So theologians are looking at what science has revealed, and they're recognizing a transformative story that's as powerful as Scripture. And scientists are looking around at reality from quarks to qualia to quasars, and they're experiencing a profound sense of awe, oneness, joy, and reverence. All words that I heard in your definitions. Spiritual experiences, informed and enriched by natural reality as science reveals it. So science is about knowledge. It's a process for constructing shared models of reality, models that people from all different religious backgrounds and ethnic backgrounds can agree on. And then if contradictory evidence comes along, we agree to seek new models that fit nature better. Now, the important words in what I just said are we and shared and agree. Science is a communal, transparent, global endeavor. So your turn again, in groups of 3 this time. Remember and then share an experience that for you felt spiritual. And keep it brief because we don't want to run way over time tonight. But just think of a time that you experienced something that felt spiritual to you and share it with a couple other people. We'll take about 6 minutes for this, 2 minutes per person. Okay. Now, in those same groups, just take a couple minutes to think about and come up with, what do these stories have in common? Are there common threads that connect these different memories of spiritual experience? All right, so what did you find? What,
2 things that I think we thought are words that could start to describe what was common. One, there was always something unknown, something we couldn't explain, something
Okay.
that just we didn't know how it happened. But the second thing is that all these situations were evocative of feelings. They made feelings.
So they were emotional in some way, and there was an element of mystery to them, or ambiguity maybe.
Yes.
Yeah, all right, what else?
Well, we have an agnostic and an atheist sitting next to each other,
Uh-huh.
and I think Rudolph would have a different way of saying what our stories have in common than I would. And you can jump in, but
Yeah.
okay. So I was thinking about when I walked in with my siblings and my father to see my mother's body.
Mm.
And I had a sense that she was okay and that she understood everything about everybody and it was okay. And whatever my story was about the end of her life and my worries about it, and whatever my father's story about it was, and that he had done everything right, it really didn't matter. Everything was okay. And we're comparing that with the first moment that Rudolph held our first baby.
Mm-hmm.
And so I was asking him, is a commonality that it's, you're going to take it from here. Okay. No. Anyway, so I would almost say, like I'm trying to like feed him, tell him what to say, right? Tell him what to think. Are you saying that it's the awe because where was Was she maybe somewhere else before she got here? Like, I'm thinking, is my mother in the common consciousness after? Um, and
It sounds like for you personally, the word that bubbles up for me in hearing your story is peace. Does that resonate?
peace, 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 and peace and love. Peace and
Yeah,
there's some
a
kind of
connection.
consciousness to
Yeah,
it.
yeah.
Yeah.
Okay. And before we put you on the spot, I should say that I intended to say earlier, if spirituality as a concept doesn't work for you, replace it with meaning making or profound, something meaningful. So,
My my story to holding my firstborn the first time came from a conversation today that I had with an old friend. We reconnected, and I said we are pretty active in our Unitarian Universalist fellowship. And he said, 20 years ago, or maybe even longer, you asked me, do you know what a Unitarian is? And he, you know, so I told him at the time, it's an atheist who just got a child.
well, we're going to talk a little bit more about awe, but I have another whole talk, actually a series of talks about awe. What the psychologists who study human emotions are finding about awe is huge, and it touches on a lot of aspects of this. Any others? Yeah.
At first, we were saying, it's nature, it's a sense of connection, but what we really decided it all has in common, it's really not a concept or a thought, it's an emotion,
Uh-huh.
safety, security, and real peace.
And maybe connection too, and often in nature. I think I'm hearing you say.
Nature is the easiest way to come to that, but there are other ways too.
Yeah.
The thing that we found in common is that this is a very strong emotion, and it's a really nice one.
Mm-hmm. The animated group, want to share any commonalities? No?
I will say, when we sit zazen, there is a deep feeling of okay,
Mm-hmm.
of the oneness.
Yeah, yeah. A deep feeling of okay. I love it. Well, for the purposes of our work this evening, spirituality is an experience and a practice. It's an experience of feeling part of something bigger, maybe something profound, something maybe sacred, if that word works for you, while also feeling deeply connected. And it's the practice of seeking this feeling and trying to live inside it as a mindset. When I study nature as science reveals it, I experience awe, which then feels like a spirituality to me. And the 7 candles of my title are 7 broad categories of revelations from science, each as challenging to my worldview as Galileo's revelation that the Earth orbits the sun instead of the other way around. So if you're ready, let's dive right in. Oh, that was supposed to be up already. Here we go. First candle, scale. So this is going to be review for many of you, but when we look up in the night sky, we see all these bright dots, right? Some of those bright dots are the 8 planets of our solar system. Sorry, Pluto, you're not a planet, but we love Kuiper Belt objects too. Some of those bright dots are stars, like our sun, 1,000,000 times the size of the Earth. But stars are suns that are much farther away, light years away. How long is a light year? Anyone know? This crowd, probably everyone knows. But sometimes people think it's an amount of time. But it's not, it's a distance. A light year is the distance light can travel in a whole year. And it's a long, long way. But some of the bright dots we see in the night sky are entire galaxies of stars, so far away that they appear as a single dot. And here's an artist's rendition of our own Milky Way galaxy. And as you can see, we're kind of out in the suburbs of our galaxy, orbiting a star so normal and insignificant as to disappear in the haze of stars. Here are some space telescope images of other galaxies outside of the Milky Way. Personally, I think they're gorgeous. Other galaxies are millions or billions of light years away. How many galaxies are there altogether? Any idea?
Almost a trillion, guess?
That's close. We can see about 2 trillion galaxies with our current telescopes. And on average, they have about 400 billion stars in each one. Let me say that again. 2 trillion galaxies, each averaging 400 billion stars. There are more stars in the visible universe than there are grains of sand on the earth. All the beaches, all the deserts. Here on the Cape, you know, there's a lot of sand, right? There are more stars than grains of sand on Earth. So in the last 30 years, approximately, astronomers have been able to detect planets orbiting other nearby stars, real close ones in our galaxy. And just since I've been doing this workshop, their estimate of the total number of planets has changed from about 150 billion planets in our galaxy alone to about 150 billion Earth-like planets in our galaxy alone. So most of the stars we see in the night sky are entire solar systems. Sure.
What do you mean by Earth-like planet?
They're rocky and about a similar distance. They're in the, what do they call it? The habitable zone around their star. So bigger stars have, it's a little further away. Whether or not they have water or life, that's a separate issue. But Earth-like meaning they could be much like Earth. Now, when we look up into the sky, we are seeing history. Even light from our own sun. Oh, I'm sorry. Where are we? There it is. Even light from our own sun takes a little over 8 minutes to get here to Earth. So if the sun were to blow up right now, we wouldn't know anything about it for 8 minutes and 16 seconds. And then we wouldn't know anything about it because, right? Well, the next closest star after the sun is Proxima Centauri at about 4 light years away. So again, if there were some big event on Proxima Centauri, big enough for us to see, we wouldn't see it happen for 4 years, until 4 years later, as the light, the image from the event, traveled through those 4 light years to get here. So if you look at Proxima Centauri this evening, the light you're seeing left the star 4 years ago and is only now reaching your eyes. If you look at something farther away, you're looking at something further back in time. And in the last couple of decades, NASA has taken a series of fascinating photographs called deep field images. They zoom a space telescope, the Hubble or the Webb, into on a tiny little patch of sky, about the size of a grain of sand held out at the end of your reach. And they choose a spot that's in between any other known stars or galaxies, pointing it at the darkness of empty space as far as anyone knows. And the first time they did this, they did it just out of curiosity. What do you see when you look out at empty space? You see this. Every tiny dot in this photograph is a galaxy, over 10,000 of them. Light from some of these galaxies traveled through space for 13 billion years before ending its long journey inside the telescope's camera. If you want to look further away than 13 billion light years, or further back in time than 13 billion years, you can't. Because 13 billion years ago, the very first stars and galaxies were beginning to form. You're looking at them in this image. We see the same thing no matter what direction we look. They've done many of these deep field images now, and this is how we know that there are about 2 trillion galaxies out there. Now, there's a phenomenon called, yeah?
How do we know that because we can't perceive them, that they don't exist beyond that point?
There are cosmological reasons for that, and we'll get to that in just a minute here. Yeah. Starting with this phenomenon called redshift that allows astronomers to look at light from distant galaxies and determine their speed and direction compared to us, kind of like the Doppler effect. And when we do this for lots of galaxies, we find that everything in the universe is racing away from us, from our Milky Way galaxy. Closer things are moving away closer things are moving away slower, farther things are moving away faster, but everything is moving away from us. It's almost like we have the cosmic plague or something. Or maybe we're in some kind of explosion or something. Everything is moving away from everything else, but further things are moving away faster than closer things. So just for the heck of it, let's run the movie of time backwards in our imagination. In backwards time, everything in the universe is approaching us, but the farthest galaxies approach the fastest. The closer ones approach more slowly. And if you extrapolate backwards, it takes about 13.8 billion years for everything in the universe to arrive right here. But the universe didn't begin with a watermelon, which I hope is obvious. It started with a singularity, which I'll say more about in a little bit. The other important difference between this video and reality is that the universe doesn't take place in a pre-existing setting. There's no table, no field, no background of trees. The universe is simultaneously both the event and the setting that it takes place in. Now, there's a lot more to say about scale. I haven't said anything about dark matter or dark energy. Everything we know about in the universe appears to make up about 4% of the total. The other 96% is this mysterious dark matter and dark energy. I also haven't said anything about the other end of the scale, the subatomic realm, but we'll get to that pretty soon here. The essence of scale is that space and time are vast, almost beyond comprehension. Looking out is looking back in time, and if we look far enough, we can almost see the beginning. And given the number of planets out there, we're probably not all alone. Flow. I want to ask you to do something a little weird. Yeah.
I had a question about the expanding universe. So if everything is expanding away from everything else, how come there are crashes?
It's not that everything is expanding, it's that space is expanding, and so you only see this between galaxies.
Right. So there are instances where large objects crash into each other.
Sure, absolutely.
So that's part of the same expanding universe, or not?
Yes, yeah. As a whole, it's expanding. But that doesn't mean on a local scale things can't still interact and collide, right?
I have a question too. It sounded like you were saying that all of space is moving away from us, like we're the center of something.
We'll get to that. Stick with me. We're getting there. So I'm not sure this is going to work, or we'll see if it does. Which is more central to your spirituality or the way you make meaning in the world? Questions or answers? Mysteries or beliefs? And what I want you to do is, if you think it's more questions, I want you to actually stand up and move to this side of the room. And if it's more like answers or beliefs, move to this side of the room. Yeah. Does what feels profound or spiritual or most meaningful to you come from questions and mysteries, or more from answers and beliefs? Oh, that's a good idea. All right, this is a room full of you-yous. We don't even need to do this exercise. Yes, I do.
The way that you missed, there's the ability.
Take the mic and explain.
I'll just say direct experience.
Direct experience. Direct experience.
You don't have to have a belief or an opinion. You don't even have to have a question. You can have a direct experience.
Beautiful. I love that. I'm going to write that down.
There's another way to be in the middle. Have your spirituality based on all of those questions, mysteries, answers, beliefs, because the answers and beliefs that other people have can make you feel very connected and very much in awe, particularly old beliefs that have grown and come along. There's no need to choose among them.
Absolutely. And that's actually why I do this in this workshop. Usually there are more people on both sides and we can talk about it and come to the realization that you just shared, that it really is both. And my tour manager is reminding me that we are not going to finish on time if I keep taking your questions in the middle. So she's suggesting, I think it's a great idea, write them down, jot them in your phone, and at the end, hopefully there'll be time for some questions. But I think a lot of them will answer as we go along. All right. Yeah. Does anyone know the compass directions in this room? If I'm remembering right, I think north is roughly this way. Does that sound? This is west behind me? That's north? Okay. All right. So if that's north and that's south, just play with me. Everybody raise your finger and point towards Canada. Come on, it's not that hard. All right. How about point towards Minnesota? How about California? Should be kind of west, right? Yeah? How about China? Okay, very good. Sue was pointing this direction. After 500 years of knowing that the earth is a ball, our brains tend to think of it as flat, right? So here we are, about 40 degrees north latitude. And I think you'll agree with me that down is towards the center of the earth, right? The folks in Australia are not upside down, because for them, down is also towards the center of the earth. So we've established that down is towards the center of the earth, unless you happen to be standing on the moon, in which case everything on the earth is up for you, right? And now down is towards the center of the moon. If you're on a spaceship in interstellar space, how do you know if your spaceship is upside down? You don't, and it doesn't matter. You don't care, right? So up and down are meaningless in that case. So basic things like direction are relative. Even simple concepts like up and down depend on where you are. If we sit as still as we can in our chairs, are we still moving? And if so, we'll say more about that. Say, how are we moving? The earth is turning.
Our cells are vibrating and buzzing, the atomic structure.
Absolutely, but I'm talking about as a whole.
The earth is moving.
The earth is turning. That's about 700 miles an hour. So that's it? That's how fast we're moving as a whole?
No.
We're also orbiting the sun, right? That's a little faster.
The galaxy is moving.
We're also orbiting the center of the galaxy, and the galaxy itself is moving, But still, we could take all those speeds into account and figure out how fast we're actually moving, right? No, we can't. Remember, everything in the universe is moving, just like in that watermelon explosion. Nothing is sitting still. There's nothing that we can compare our speed to that isn't also moving. So speed is relative. Even location is relative. Remember, if we run the movie backwards, everything in the universe comes back to right here. And cosmologist Brian Swimme said it this way. He said, the universe does not expand into a pre-existing space. Space unfurls with the universe, end quote. And this is really hard to imagine. So let's let this balloon represent the universe. And what we're doing in this analogy is we're collapsing the 3 dimensions of space down to the thin rubber of the balloon. Okay? So if you want to get from one galaxy to another, you have to crawl like an ant on the surface of this balloon. Now, pick one of the stars on the balloon to represent our galaxy or our local group of galaxies. It doesn't matter which one you pick. All right. The universe expands because space itself expands. Watch. See how all the stars move away from the one that you picked? And the farther ones move away even faster than the closer ones. All right, so let's run the movie of time backwards in the balloon. As I let air out, everything approaches the star that you picked. Further ones faster, closer ones slower. But when we get back to the beginning, we don't get either a watermelon or a limp balloon. Instead, the laws of physics dictate that everything collapses down to a singularity, an object containing the whole universe, but compacted infinitely dense. So our universe started out as one thing, a thing with no height, no width, no depth, zero volume, a singularity. Now, let's begin time again. And this is where we find ourselves in an expanding universe. Which point on the balloon represents the center of the universe? Every point and no point. Both are equally true, even though they're opposites. And this is called the cosmological principle. Even though the two answers are opposites, both are correct. So, distance, speed, even space itself, all of these are relative. They're flexible. And Einstein showed us that time too flexes and flows depending on your speed, which we cannot know in any absolute way. And I understand some of you are reading a book about now, about what the concept of now means. I'm looking forward to reading it myself. So the essence of flow is that there are no anchor points. Everything's in motion. All is process. All is flow, even time and space themselves. Everything began as one thing, and the center of the universe is wherever you are. So try not to let it go to your head. So I want to give you a minute, just a moment, to write down any thoughts that are coming up from you. What are the bedrock anchors of your spirituality or your meaning making? What are the processes and questions and unknowns that help you to evolve and blossom? And if you have paper, you can write them down. If you want to jot in your phone or just file them away. Anne has paper if people want. All right. So I asked a group of elementary students a couple of years ago, where did all this stuff come from? And their answers were kind of surprising. So I want to ask you, where did all this stuff come from? Stuff, objects, things. This, the chairs, your body, everything. Yeah, very good. You're a few minutes ahead of me. All right. So this group knows more than the elementary students. That's good. But let's go through it because I think it's profound. At the beginning of time in our universe, there was only energy. No atoms, no matter, no mass, not even any space. No solids, liquids, or gases. There was nothing that we would call a thing, just pure energy. Now, matter and energy are like nouns and verbs. Matter is stuff, things, objects. Energy is movement, action, ability. So how did the universe make all this stuff if all it had to work with was energy, light, bright light? Well, at extreme energy densities, matter can actually condense out of pure energy. And in the first moments after time began, particles that would later form the first atoms of hydrogen and helium condensed from extremely bright light. Now, in a normal science lecture, I might say that and just move on, but let's pause for a moment and contemplate this. Matter from energy. This is nouns made from verbs. Like in the sentence, girls are running, everyone knows that girls can run, right? But the action of running cannot become a girl, or vice versa, right? She can do running, but she can't become running somehow. It doesn't make any sense. And yet here we are in bodies made from light. So the evolution of matter from energy is like a miracle or something. It's a scientifically described miracle, but it's no less miraculous just because we have an equation for it and we know that it's a real part of natural history. All right, so the early universe had some hydrogen and a little bit of helium. That's nice. Now what? What can you make if all you have to work with is hydrogen and helium? Not much, right? There is one thing you can make: stars. Stars make heavier atoms from light ones because it takes really high temperatures, like the temperatures inside our sun. And if they're moving fast enough, two hydrogen nuclei can crash together and stick, making a helium nucleus. Then another hydrogen can crash into the helium and stick, making lithium, and so on, making or fusing heavier and heavier atoms. Lithium, carbon, fluorine, and so on, up to iron. This is nuclear fusion in stars. But normal stars like the sun can't make anything heavier than iron. And anything they do make is just going to sit inside the star forever. It won't get free to make planets and stuff. So none of the stuff in this room came from normal stars. But there are some supermassive stars. They have to be at least 10 times the mass of our sun. And these stars, at the end of their serviceable lives, they get sort of hollowed out until they implode. Gravity pulls everything inward, collapsing suddenly inward. And during the brief moments of that collapse, temperatures are high enough to fuse all the heavier elements that we find in the world. But then the star rebounds, it explodes and spews all those fusion products, all those precious heavy elements out into the surrounding space as hot stardust in a massive supernova explosion. And later, that dust cools and is gradually collected by gravity into new solar systems with new planets like the Earth. So somewhere in this part of our galaxy, about 7 billion years ago, some supernova stars exploded, creating and then bestowing the elements that make up everything in this room. including our bodies. You could say those stars are our ancestors. So the essence of stardust is that your body and everything else that's made of matter is a condensed form of bright light, energy explosively forged into matter at the beginning of time, and then built up in the furnaces of dying stars. You are the universe, made of itself, but now aware of itself. So how might life be different if you could remain conscious and aware of this stellar ancestry as you go about your day? Would it change anything? Any thoughts about that?
You realize how integrated you are with the cosmos, and that you are the cosmos.
Yeah.
So when you're asked how old you are, tell them you're 13.8 billion years old.
Yeah.
I actually always tell people I'm 13.8 billion years old. If we're all made of this light, then there is no actual separation from that light, and there is nothing that you can't perceive from that infinite light, and you can have a direct experience inside yourself of that infinite light and retrieve all information from there.
Joe? I think life might be different in that we'd all be healthier.
Say more about that.
The capacity to process change is a way of metabolizing light, which dissolves the stuckness that can be disease.
Mm, mm.
Could you say that again?
No. I could probably say it a few different ways.
Could you, no, seriously, could you say that again or a different way, or it just was a lot for me to.
Well, I'll start from the end point about disease being stuck. So what removes obstacles or what dissolves them or metabolizes them is energy, which is light, which is.
So being
We'll
conscious,
all be healthier. Is what.
being conscious of our interconnection and our oneness with that original light would help us be part of a flow rather than a stuckness. Is that what you're saying? Uh-huh.
Experience of permeability.
Suppose there,
Yeah.
suppose there's a circuit in your. I'm sorry. You have to hold it closer. Suppose there's a circuit in your brain that we call the awe circuit, and the criteria, the features you've described, like scale and mystery, all evoke or stimulate that circuit. And that circuit lives in our brain. I'll give you a bit of evidence that there is such a circuit. If you want to experience awe, just take a dose of psilocybin.
Mm-hmm.
Psilocybin will evoke my hypothetical awe circuit.
Mm-hmm.
And so what you're doing is describing the criteria for evoking that awe circuit. And then people interpret that, in their personal dimension, as being more or less religious or spiritual.
Mm-hmm. Absolutely. Yeah. I have a colleague named Dr. Calvin Chatlos, who is a psychiatrist and a neurobiologist, and he would completely agree with you. He doesn't use the same language, but
my point is that I don't think you can necessarily say when you've experienced awe that there's something more.
people are going to make their own meaning from that, out of that experience.
Right, and
absolutely,
very
and that's okay. I don't need to know which interpretation is the right one. Probably all of them and none of them. The question I'm asking is, how would it change your behavior? How would it affect your life if you could live there?
It would help accept change.
Okay?
Because if we've been going through it for that long, and something small that happens to us now is not such a big thing.
Yeah, keeping a deep time perspective. Yeah.
I guess for me, taking that in as an understanding is very kind of a continuation from almost like Native American belief that you're part of this earth, you're part of all of this, and to me, it would be very helpful for people to believe that they're part of this bigger picture because we would take care of it better.
Yeah, sure.
Back to the everything's a miracle or nothing's a miracle kind of thing.
Yeah, I don't agree with that, but
I'm thinking maybe just because a sense of awe can be connected to a switch that you can switch on with a chemical, there might still be that's awesome.
sure. Yeah, absolutely. All right, we are definitely going to run out of time if I don't press forward. All right, so we're made of atoms that were made by supernova. What do you know about atoms? Well, you're probably picturing something a little bit like this, and that's a handy model for some purposes, but it's a gross oversimplification and is never to scale. Atoms just aren't like that. So to get a better picture, let's start with the simplest atom, hydrogen. It has one proton in the nucleus and one electron zipping around the outside of it. Let's enlarge that proton so it has the mass of a cannonball in our imaginations. So you can picture a grapefruit-sized piece of steel. At that scale, the electron in our hydrogen atom would be zipping around about a mile away. So if we apply that same scale to an atom of iron, you'd have to imagine a pile of 56 cannonballs here on the floor with 2 BBs zipping around about a mile away, 8 more BBs about 2 miles away, and 16 more about 3 miles away. Could you see them, the BBs, from here? Not a chance. And then about 7 miles away in each of several directions is the next pile of 56 cannonballs on the floor, representing the nucleus of the neighboring atoms in a piece of iron. What's between this pile of 56 cannonballs and the ones 7 miles away, aside from those tiny BBs that are zipping around? Nothing. Nothing. Empty space. Even solid iron is 99.9999% empty space. But I misled you by showing you pictures of cannonballs and BBs because subatomic particles aren't little balls. They're not even things as we would normally conceive of that word. They are phenomena. They're events that sometimes act like things, but they're not things. Let me show you. Here's the basic setup of a single slit experiment. This is a classic experiment in quantum physics. You make a very thin slit in something opaque and then shine a laser on it. And you might expect the laser beam to go straight across and make a laser dot here on the opposite wall. But if the slit is narrow enough, something interesting happens. The light bends or diffracts around the edges of the slit, and it goes off in all directions. The brightest area is opposite the slit, but then it tapers off gradually towards the edges of the screen. And when we're talking about light, this actually makes complete sense because we know light has wave properties, and waves do this, whether it's light or sound or even water waves. So you may have seen diffraction happening in a lake or the ocean where there's a gap in a jetty or something. Just for giggles, let's do it again with 2 slits right next to each other. Here again, the light bends or diffracts around each slit. But now the light from each slit gets superimposed on the light from the other slit. So these 2 different waves interfere with each other. Any place where you have 2 wave crests or 2 troughs together, you get bright light. But if a crest and a trough meet, they cancel each other out and you get darkness. So instead of the two bright laser spots that you might expect over there, you get alternating bands of light and dark, where the waves either add or cancel. And the brightest bands are across from the slits, but then they get dimmer as you go out towards the edges. Still, all waves do this, including light. It's not actually all that interesting. But now let's replace our laser beam with a cathode ray, a beam of electrons. The same thing happens. Physicists have even managed to shoot a single electron at a double slit apparatus, and the electron goes through both slits simultaneously, interferes with itself, and makes the same pattern on the screen. This is true of electrons, protons, neutrons, even whole atoms and molecules. They all do this. They can't be little balls. There's something more mysterious than that. Now, I've barely scratched the surface of modern physics. It gets weirder. It gets a lot weirder. But the essence here is that the things we think are most real, most tangible, most solid are by nature more like phenomena, stories, processes, energy. Matter, even now, is made of verbs, not nouns. Now, I was raised in a New Age family, and I know how pop culture depicts New Agers. You know, the stereotype with a kind of yoga hippie space cadet with flowers in his hair says, "I am a being of light," right? Well, that much is true. We are beings of light in a hard-nosed, show-me-the-evidence scientific way. And here again, what's real has more to do with process and potential than with things and objects. The stream more than the rocks. All right, I have time here for a stretch. Does anybody need to use the restroom? If not, let's just forge ahead. That'll save us a little bit of time. All right, evolution. Both the process and the history. Well, the process of evolution is fairly simple. Darwin's insight had 4 basic tenets. The first was surplus reproduction. More offspring are produced in each generation than are going to survive to have offspring of their own. Those offspring vary one from another. They're not all clones of each other. They're different. Those differences are heritable. They get passed down by the survivors to their own offspring. Since we know not all will make it to have offspring of their own, some of those inherited variations will bestow an advantage, and other traits will make for a disadvantage. And the ones that provide an advantage will in turn get passed on to offspring. The disadvantageous traits will get passed on less or not at all. If you apply this over many generations, we would expect that if it's to a horse's advantage to be larger, that horses would get larger. And that's exactly what we see in the fossil record. Horses used to be the size of cats or lap dogs, and now they're big enough to ride on and pull beer trucks around. And of course, it's not just horses. We see this all over the record. Shorter generations can make for faster evolutionary change. So right now, your skin is covered with Staph aureus bacteria. Don't freak out. It's a good thing. They actually protect our skin from pathogens, from bad guy germs. They produce a new generation every half hour. So if you expose Staph aureus to intermittent or dilute antibiotics, in a matter of weeks, they can evolve into something more like MRSA, methicillin-resistant Staph aureus, which can be deadly. So what does all that mean for us? Well, we are here because our ancestors survived to produce us. And they survived because they had what it took at the time, traits which they passed on down to us. Those traits, all of them, make us who we are, even the ones we don't necessarily appreciate about ourselves. So what are your icky traits? I'm not going to ask you to share out loud. Vanity, lust, rage, addictions, jealousy. Some people would call those sins. But whatever we call them, these are traits that our ancestors needed to live long enough to make our births possible. If they're not well suited to our current environment, then, let's learn to control and manage them. But what if we embarked on that process with a sense of gratitude instead of shame? Feeling grateful for my icky traits sounds weird, but I don't think it's misplaced at all. They were necessary for me to even exist. And, recovering addicts will tell you that gratitude just works better when you set about transcending unhelpful parts of your nature. There's another implication for us here having to do with death and evolution. We are programmed to avoid death and to grieve the death of those we love. But consider that the flip side of our ancestors' survival is the necessary death of our evolutionary aunts and uncles, like the dinosaurs. We wouldn't be here if they hadn't made way for us by dying. And we too, each of us, will someday make way for something new by dying. Plus, we live by eating, which necessarily means killing, even for the vegans among us. When you bite into a fresh apple, the cells of that apple are alive until you ruthlessly slaughter them with your pointy teeth. Does this mean we're horrible, vicious apple killers? I think it just means that life and death are inseparably connected. Stars die and their ashes form new planets. Plants and animals die and their bodies make other bodies, including ours. Endings are also beginnings. Death is necessary. And from a really big picture point of view, I'd say death can be beautiful. It's beautiful because it's an essential ingredient of life. Okay, I am going to ask you to share an icky trait, but you can pick a really, a gentle one that's not more revealing than you're comfortable revealing. So in pairs, share a trait of yours that maybe you're not all that happy about, and consider together how it might have been helpful to your deep time ancestors. And then ask yourself, can I be grateful for this? Just take a couple minutes for this one. I know I'm rushing you, and I apologize, but I really don't want to make you drive home in the dark. Take another few, maybe 30 seconds. All right. I wish we had time to hear some of what you came up with, but let me just ask, is gratitude possible? Did you find, maybe you could find gratitude for this? Cool. All right. Still on evolution. I am sorry to cut you off. I wish we had more time. I want to lift up 4 really significant milestones in the story of evolution. And I do this because a lot of people think it's all about competition, survival of the fittest. But that's only half the story. The biggest leaps in complexity on this planet have come about as the result of profound cooperation. The first milestone is that life began at all. Somehow, atoms and molecules assembled themselves into arrangements that were self-replicating. This is a little bit like matter from energy. It's a wow moment in our natural history. It's not your everyday occurrence. Is it cooperation? I think defined broadly that it is. The next milestone is clearly cooperation, and that is that some of those early bacterial cells took up residence inside their neighbors' bodies. And this was called the eukaryotic revolution, when membranes within membranes allowed cells to get way more complex. For example, your cells have a cell membrane around the outside, but then they also have a membrane around the nucleus of each cell where the human DNA in your chromosomes hangs out. Bacteria don't have that. Even more telling are the mitochondria. Each cell has dozens of these mitochondria, these tiny organelles, sometimes called the powerhouse of the cell. And the mitochondria convert sugar back into energy so you can do everything that you do. But each of those little mitochondria has a membrane around it, and they have their own DNA in little circular chromosomes, like bacteria, circular chromosomes. And the mitochondria in every cell of your body are the descendants of ancient bacteria that inserted themselves into the bodies of their single-celled neighbors and stayed. They stuck around, providing useful cooperative functions from the inside. Every living thing except the bacteria are descendants of the eukaryotic revolution. The third milestone happened when some of those eukaryotic cells began to clump together in cooperative groups or colonies. And this allowed them to share resources and to signal each other, and eventually to specialize into tissues and organs. A single cell can't do that. Again, incredibly powerful innovation with huge mutual benefits for all the cells involved. The last milestone is when entire eukaryotic multicellular organisms began to work together in societies that function a bit like large collective organisms. Here we're talking about bees and ants and wolves and people. As a natural process, I think it's fair to use the word evolution to mean not just the evolution of life on this planet, but the history of the whole universe. And in that context, we see ourselves as part of a great story, a story in which energy evolves into matter, which makes up atoms that bond into molecules that then coordinate in cells, that evolve into tissues, which cooperate to make organs inside organisms, which work together in societies like tribes, villages, and then nation states, federations of nations. I would say all of this is a kind of evolution with cooperation at every step. Now, the obvious pattern here is that as time goes by, the complexity of the most complex system in the universe increases. Now, when I see a trend like this, I always want to go up to the far right end. What's next? And Yogi Berra famously said, "It's tough to make predictions, especially about the future." But if that trend continues, we could guess that whatever comes next will involve new levels of cooperation, which could give rise to whole new scales of complexity. One thing we can be sure of, though, until time ends, evolution is not finished. We're the middle of the story, not some end product. The essence of evolution is that we are survivors, built from blueprints that were slowly refined by our ancestors' continued existence. We could choose to be grateful for our virtues and our vices because they made our births possible in the first place. And then in the continuing evolutionary process, death is a gift from the past that we will each in turn pay forward. I have separate talks and workshops on shame and death, and there's a lot to learn from a deep time perspective. I hope you'll agree that such topics are in the domain of religion and spirituality in a way, and that science offers some insights as we grapple with them. Sixth scandal, emergence. So here we are in the middle of this evolutionary story, but who's we? What do I mean when I say I? Am I just a collection of atoms operating according to the laws of physics? Am I just a soup of chemicals bonding and unbonding according to the laws of chemistry? Am I just a colony of cells like corals, each cell just trying to live out its own destiny? Well, the answer to each of these would be yes, except for one word. We are made of cells, which are made of molecules, which are made of atoms, but there's nothing simple or obvious about any of that. Atoms made from nothing but light, molecules coordinating their own replication, trillions of amoebas cooperating to play the saxophone. Well, yeah, but you don't get any music unless the cells, the molecules, and the atoms, each arguably a miracle in its own right just for existing, you don't get the music until they're arranged in a very particular and precise arrangement. And when that happens, the whole is greater than the sum of the parts, and we get another miracle, music. Similarly, a pile of steel and plastic can't get you to Grandma's house for the holidays unless the steel and plastic are shaped and assembled just so. But a car doesn't assemble itself. You did. And a human body is far more complex than a car, with uniquely human emergent properties like poetry and logic and faith. Emergence happens when new scales of complexity give rise to new properties. So, for example, hydrogen and oxygen share electrons and make possible oceans and rivers and clouds. Some cells cooperate together. I think we missed a slide here. Some cells cooperate together, and before long you have senses, flight, sexuality, and consciousness. A few primates live in groups together, and you can have language, culture, morality, governance, religion, and technology. At each transition, there are three principles operating. Cooperation provides a competitive advantage. Simple things come together to make more complex things, and then new properties emerge that were not possible before. And you can say the whole is greater than the sum of the parts. Like you, this universe is self-assembling. Your body is the cutting edge of self-assembling complexity in the universe. So the essence of this candle is that cooperation and competition work together to increase complexity, and then that brings new emergent properties that were previously impossible. And we can say the universe is creative. Seventh candle. Take a deep breath with me and hold it. And while you're holding it, think of someone who lived long ago and far away. Could be anyone. Who are you thinking of? Anybody? Just call it out. Your grandfather. The first person. Harriet Tubman. Genghis Khan. All right. Well, you can breathe. I didn't mean to make you hold your breath that long. Well, you just breathed in over 13 sextillion air molecules in each breath. Over 700 million of them were also at some point inside the lungs of the person you were thinking of. Something similar is true of every person who ever lived. Also, every animal that ever lived, every plant that ever lived. They are, in a way, all here in the atmosphere of this room with us. Some of the oxygen molecules from that breath you took now are you, part of your body, come alive through being part of you. You might recall that photosynthesis allows plants to make themselves, to make their bodies out of carbon dioxide and water using energy from sunlight. Well, we make ourselves out of plants, either directly or indirectly. So we too are made of CO2 and water. So I want to take a closer look at those. Here's a diagram of the water cycle. You've probably seen something like this before. And water evaporates from the ocean and drifts over the land, and sooner or later rains or snows back down and finds its way back to the ocean. But there's something missing here that's missing from pretty much every water cycle diagram I could find. It's us. One of the things some of the water does as it goes around its cycle is spend time being us. Every sip we take of any beverage contains water molecules that were recently posing as clouds, as waterfalls, hurricanes, glaciers, and other living things. And they're about to be posing as you. So the magic is that water comes alive when we drink it. Water comes alive in us as we drink it. And you know, something similar happens with the carbon cycle, except that carbon spends time posing as things like seashells and coal and limestone, concrete, as well as other living things. Some of the carbon atoms in your body right now were a fresh apple last month. And a few of them were gasoline in my car last winter. And now they're in you. They're alive as you. Same thing happens with the nitrogen cycle, the oxygen cycle, the phosphorus cycle. All the elements that go into living bodies have cycles like this. We are embedded in those cycles. We're not separate from them. Every year, about 98% of the atoms in your body get exchanged for new ones. So your body is like a standing wave on a river. There it goes. Matter moves through you, takes your form briefly, and then moves on to be something else for a while. So our bodies aren't really things, they're flows. Or maybe more accurately, our bodies are complex patterns in the flow of matter around the earth. Not sure how those got out of order. And I'm sorry to report that other living things flow through us too and become us temporarily as they do that. And I'm mostly talking about bacteria here, although protists and fungi participate too, even some insects. On and inside us, bacterial cells actually outnumber our human cells. There are thousands of species, trillions of cells, all cooperating and competing with each other and with our human cells all the time. They digest our food for us. They protect our inner and outer linings. And microbiologists are finding that the species on and in us influence when we're hungry and thirsty, our food preferences, our weight, and even our emotions. So, is it me who loves cheesecake or we? Remember those mitochondria, ancient remnants of bacteria still operating in every cell of your body with their own DNA. Well, all of your mitochondria came from your mother, who got them from her mother, and so on. They're inherited matrilineally. And paleogeneticists have been able to use the well-established mutation rate of mitochondrial DNA to determine that every human being alive today descended from one woman who lived in Eastern Africa only about 200,000 years ago. Every human being alive today, regardless of race, gender, ethnicity, we all share a common great-great-grandmother. And this is National Geographic's map of how we got from Africa to all the other continents. So look around at the people in this room. These are your cousins. There's only one family of people on the earth. And of course, it's not just people. We share half our genes with bananas, our most delicious cousins. All living things are related. We are part of a single unbroken family tree that stretches back 3.5 billion years. Now, there are many more examples of our connection and unity from science, but the bottom line here is that we can't really separate ourselves from the earth. We are Earth. Earth is giving this talk this evening, and Earth is sitting in those earthen chairs listening. We and it are us. One thing, one life, one universe. So the essence of this last candle is that you are neither separate nor even separable from other people, other creatures, the earth, ancient stars, or the universe itself. You are the universe come alive. Now, sometimes people come up to me after I say all of that and they say, well, that was a wonderful science lecture, JD, but where was the spirituality? So I want to give you a minute to consider that question for yourself. Was there any profound meaningfulness to any of this?
I don't see how you can distinguish everything you've talked about from spirituality.
Yeah.
All the interconnectedness and the universal life force energy flowing through everything.
Yeah, that's where I'm at with it. Any other comments?
I mean, it's a nice story that you're telling, and this story is told in every tradition in different mythological ways and different characters. And if you want to come to our story about Peru and how they tell this story, because it's the same story, told in different ways, but they understood all this. And so that's what we're going to talk about at our talk.
Beautiful, yeah. Well, here are some broad categories that stand out for me. Was someone else about to share? Okay. Discerning our place in the universe. Grasping for constancy and finding it's all about change. Learning the first origins of our bodies, our genesis, if you will. Exploring the illusions at the heart of reality, the dreams that stuff is made of. Insights into life and death, virtue and vice, cooperation and competition. Exploring creativity in a self-assembling universe. And the oneness of all life, even of all things. For me, taking nature to heart as well as to mind has deepened my own spirituality. As Carl Sagan said, science is not only compatible with spirituality, it's a profound source of spirituality. The notion that science and spirituality are somehow mutually exclusive does a disservice to both. So I hope that after today you'll put that old binary behind you. So whatever your beliefs are about God or prayer or other realms of existence, this reality, natural reality, I think offers profound insights for spirituality and meaning making. And when I take nature to heart, nature is enough for me. So as you leave here, I hope you'll remember that you are both central and diffuse, temporary and ancient, flawed and fine-tuned, creation and co-creator, certainty and mystery. We are the universe, become conscious, glimpsing our vast and ancient self for the first time and wondering, what will we create next? Thank you.